All right, guys. So, welcome to distance learning again. Remember, like Dr. Dunn said, make sure that it's learning. So, you have to be doing your work, watching the videos, things like that. And so, for this class, there's just going to be a few videos and a few worksheets, nothing crazy. Like I said, I don't try to give you too much. I try to give you about maybe 2 hours of work. So, just 1 hour per week that you have to set aside to watch the videos and do the worksheets. It might take a little bit longer if you're not comfortable with the subject, but that is about how much time you should be spending. So not anything that's too much. So what we're going to be talking about in this time during distance learning is all about chemical bonding. So here's the PowerPoint that we're going to be going through. So it's chemical bonding. Make sure that you have your notebook out so you can be taking notes and following along as we're going through it. All right. So pull that out, and I'm going to go over some bonding basics. Also, during this time, I might be going too fast, so you might have to pause the video to write down the notes and then maybe listen to me talking, okay? So, the first thing with bonding is that when we talk about bonding, electrons are the things that are responsible for it. So it's not necessarily dependent on the number of protons or the number of neutrons, it's based on the electrons. And so that's why we've really been talking about valence electrons and things like that, because that is what is going to determine our bonding. So elements bond because they're trying to get to 8 valence electrons. We've talked about ions, how they form because they are trying to get to 8 valence electrons, and so that's why they bond. And we're going to look more at, ions and things like that because those are going to be involved in bonding. Another just vocabulary word that we're going to need to know is that a molecule is 2 or more atoms bonded together. So we have to make sure that we have those two molecules that bond together, or two atoms that are bonding together. That's going to be a molecule. We're going to use that term a lot. And most of you guys probably know it, but I just wanted to make sure that we all knew what we were talking about when I say the word molecule, that it's two atoms that are bonded together. All right, like I said, you might need to pause to finish writing. I'm going to keep moving on so that the video is not too long and that you can go at your own pace. If you are done writing, but we'll keep going. All right, so there's 3 different kinds of bonds we're going to talk about. This video, we're going to focus on ionic bonds. So the definition of ionic bonds is right here in the bold. It's when their electrons are transferred between atoms and they are held together by positive opposite charges. So we're talking about electrons totally being transferred. So it's when it's like they create ions, and some of them give electrons and some of them take electrons, and then some will have a positive and some will have a negative, and then they're going to be held together because one is positive and one is negative. Remember, opposites attract, so they're held together by the opposite charges. These are known as our strongest bonds. So those forces of attraction, the positive and the negative, is really strong. And it's going to be between metals and nonmetals, which kind of makes sense. Because if you have your periodic table out in front of you, you know that metals, like in this category, this one, and then over here, that these metals create positive ions, right? They really give up their electrons really easy. These nonmetals over here, they create negative ions, right? They take electrons really easy. So nonmetals and metals are going to pair really well together because this Na is going to give up an electron really easy to this Cl. And then they'll create positive ion and a negative ion and be attracted. So we're going to look at a visual of this because I know that's probably going to be the most helpful thing. So make sure you get down all this information and then resume the video to look at the picture, okay? So this is our visual that we have. We have Na and we have Cl. Like on the other side, we saw Na, it's kind of on the left side of your periodic table, and then Cl is over on your right side. So it's a non-metal and it's a metal. So Na doesn't really want this electron, right? It's going to be way happier if it gets rid of it. Cl really wants one more electron. So Na is going to donate its electron to Cl. Cl is going to be able to pull that all the way off of Na. And then you're going to have this that's going to form. We see that the Cl now has all the electrons around it, and the Na has none of the electrons. And what's holding them together is this positive and this negative, is how they're able to hold together. So that is ionic bonding, an explanation. Now we're going to talk about some properties of it. So here are some properties. This is really important because on your test, they're going to be asking you, like, An element has these properties. Is it ionic bonding or a different kind of bonding? And so you need to be able to say that, be able to identify it based on the properties that it has. So ionic bonding has a crystalline structure. So that means it is kind of set up in a certain way. You can see salt has a crystalline structure. It makes it so that it's easy to break or crumble, like salt kind of is. Um, the next part is that it has a high melting point. So that means it doesn't melt easily. So that means if you put it in a pot and try to melt it, it won't melt very easy. So it's usually going to be solid at room temperature. So, like salt is solid. If you put it in a bowl and try to melt it, it's going to take a lot of heat to melt. The next thing is conducts electricity. And so that means if we mix it with water, it's going to be able to conduct electricity. We'll look at a visual of this in class. But salt, if you mix it with water, it's going to be able to conduct electricity and light up a light bulb or things like that. The next thing is that it's soluble, which basically means that it dissolves in water. So it mixes well with water. And we'll learn about why that is later on. But ionic bonds, they'll mix well with water. So you can do these certain tests to be able to see what kind of bond is happening, because you can see if it has these properties when you conduct certain tests. And hopefully, when we get back into class, we'll be able to do those, depending on the timing of everything, okay? So there's another term that you need to know. It's called polyatomic ions. So normally, when we're talking about ions, we talk about just one element that has a charge and another element. So it is Na plus and Cl minus. But these are groups of bonded atoms with a charge. And so an example of that is NH4 plus. So you see this whole group of bonded atoms, and then it has the charge. Another example is CrO4 minus. So this whole group has a charge. By itself, it's not going to have a charge. But when it's all together, it has a charge on it. So sometimes these things are used in reactions where, like, for example, it'd be like Na plus is attracted to the CrO4 minus. All right. So that's just something to keep in mind. Your test might ask you, like, which one of these is a polyatomic ion or things like that, but we'll do some practice. So the next thing we're going to talk about is covalent bonds. I'm actually going to do that in a completely different video. So take a break if you need to, come back and watch the one on covalent bonds.